Good evening, everyone. Welcome to class number 11 of Advanced Course in Drones for Development. Over the last 11 days, you must have heard a lot about what flying labs are. Almost all of us have been talking about flying labs. So, what are flying labs and how do we really function? We Robotics is a mentor organization, and we all are in different countries operating a local hub, knowledge and activity hub. And we really believe in sharing openly whatever we learn, whatever we do with everybody. And we're building this kind of a learning community wherever we are. So, in today's session, we will be learning a little bit more about how complex projects like healthcare drones are actually implemented. We heard from Olivia yesterday that when we work with the governments, there is a long journey from when the decision is made till when actually the drones fly. Today we will be hearing a similar story from the team in Nepal. Last time we heard from Jurg from V Robotics about how he set up the entire technology, the drones, the corridors, and the communication systems, the apps. So that was his part of the story. Today we'll be hearing from the team in Nepal all the struggles that they had. In Hindi, we call papad velna. So that is like a very simple way of saying it, that it's a long, arduous journey when you're talking about drones in healthcare. And so today we will be talking to Biplav Pageni from Nepal Flying Labs, and he will be joined by his colleagues from Nepal Flying Labs who have actually flown the drones, who have actually sat with the government, took permissions, ensured that the customs were cleared and everything. But let them tell you about all the struggles and all their part of the story. This will really help us in making our mind that tomorrow, when we have to lead these projects in our countries, how do we really go about? What do we need? And how do we prepare our teams? How do we collaborate? How do we partner up? How do we find funding? A lot of this today. So I'll request Pipla to please come online and let's see your face first, and then we can begin.
Would like to show why we should use drones for rural healthcare. It is a known fact that more than 80% of Nepalese population live in rural areas, and among them, 50% are living in mountainous and hilly regions without access to good healthcare facilities. Normally, it takes more than 6 hours to travel between a house and a proper healthcare facility. On top of that, the density of qualified physician in the country is just 0.74 per thousand population. And as we move towards the western rural Nepal, it just drastically drops down. People are dying from simple diseases due to remoteness of villages, and health facilities are not easily accessible. As you can see in the slide, it takes a long time to travel through road indicated by the red line, while a drone can fly right across the hill, reach the destination indicated by the green line. The reason for poor rural healthcare are due to these forcing causes. Firstly, the laboratory in rural areas are not well equipped, and the medical personnel tend to stay at locations with proper healthcare facilities. Along with that, there have been instances like drug stock out of many of the 22 essential drugs. And on top of that, youth in rural places migrate to cities and other countries for various opportunity, leaving the most vulnerable behind. The lack of proper accessibility to infrastructure that stems from harsh topological condition is the chief reason why Nepal is having one of the poorest rural healthcare. Here you can see how sick people are being transported in rural Nepal, which can take hours of long hike up and down with harsh and narrow trails. Therefore, we aim to use drone technology to aid rural healthcare through this project. In Drone Optimized Therapy System, also known as DROTS, we facilitate the collection of sputum samples for rural location in Bhutan district for rapid diagnosis using gene expert diagnostic tools. As shown in the slide, we are aiding to find the missing tuberculosis cases in western rural Nepal, Bhutan, which is 450 kilometers west of the capital city Kathmandu. For this project, we are using customized DJI M600 drone, which is 15.5 kg in total weight and carry a load up to 1 kg in its customized 3D printed cargo box. The cargo box is developed with compartments that can carry up to 16 sputum samples. The drone is controlled with this ground station application, which has all the features that a regular drone remote control has, along with some additional features for autonomous landing and flights. This application can be used in any Android device. However, we use tablets as it has bigger display. The community health workers visit houses of the TB patient, screen their contacts, collect sputum samples, and provide it to the nearest health post. 2 drones lab with gene expert machine has been established at Bhutan District Hospital and Bhingri Primary Healthcare Center, from which the drone is dispatched to other rural health posts. Firstly, the drones are flown to rural health post, where the drone is landed by the in-house personnel or through precision autonomous landing feature. The clinical samples are then loaded into the drone cargo holder, and finally it is dispatched back to the drone lab for diagnosis. This was successful by going through 8 implementation phases as shown in the chart. It all started with the formation of project committee, which consisted of BNMP as health partner, Drone Nepal and Nepal Flying Labs as technical team, Caerobotics as a team leading drone customization and software development, Stony Brook University as a project management team, and Liverpool School of Tropical Medicine as the team providing mentorship and capacity building for research and laboratory strengthening. We had to knock on several doors of these listed government agencies, which was one of the most stressful phase of the whole project. As this was done for the first time in Nepal, a lot of things had to be explained to bureaucrats. After hassling for months and months, we were able to receive permission with the help of these 12 government agencies. Then the fieldwork started with community engagement program, where we organized different level of sensitization workshop. As it was crucial, an initial need before the inauguration of the whole project. Community consultancy and sensitization workshop were organized at district and municipal level to educate the local people and officials about the benefits of this technology. Most of the rural areas in Nepal lack accurate updated maps. The pilot team required high-resolution map of healthcare facilities to plan tentative takeoff, landing, and emergency landing sites. 12 health post sites and the 2 healthcare centers were mapped by the technical team. Then using this map, flight routes were carefully created using our quality ground control software for each site. Intermediate station or emergency landing zones were created for each path. The following considerations were taken into account while planning the flight route. After a series of test flights and detailed field mapping, the technical team were ready to start the operations. On 22nd June 2019, the project successfully inaugurated in Bhutan district. The program was an extravagant affair with active participation of the following government agencies. The first official flight took off from Bhutan Hospital to Dharmamati Health Post on June 16th. Flights were operational on 8 out of the 12 health posts, and drone flights were carried out from Bhutan Hospital and Bhingri Primary Healthcare Center as shown in the figure. In average, weekly 80 sputum samples were transported. All the flights were fully automated and precision landing improved the landing accuracy. The longest route recorded was 6.7 kilometers, and flights were conducted 5 days a week to 8 of the health posts from 2 centers. As you can see, the flight schedule is shown in the slide. Friday was kept for the maintenance purpose. To make the project successful, we had to go through a series of technical challenges to reach this level of our capacity. As I already mentioned, we had to deal with the permission process for months. And moving on to the field, we faced different meteorological and technical challenges. The GSM network or the mobile network suffered from a high latency and unavailability, and the accuracy of GPS was not optimal for autonomous landing. The unreliable weather had halted the operations several times. On the other side, the non-technical staffs who were needed to operate the drones for sustainability and expansion of the project had a hard time to get to know how to operate these systems. To tackle these challenges, these were the solutions that we take. A custom low-powered network on the 2.4 GHz bands was added in our system. The range of the radio was limited to 2 to 3 kilometer line of sight. Therefore, in order to keep the constant contact with the drones, on each route, multiple relay stations had to be installed. Different weather protocols was dispatched and landing sites before each flight was established, and operations were stopped during uncertain weathers. A simple step-by-step user interface translated in Nepalese language was developed for aiding the ease of operations to the non-technical staffs. For the landing accuracy, additional module has been developed and added to the drone using a ground-based QR code mapped at the landing site in order to enhance its positioning capacity during the landing process. Overall, we were able to make the drone autonomous, simple to use, reliable, and affordable to operate. Here are the major outcomes of our project. Currently, the drones are fully operational since June 2019, which connects a primary healthcare center that is seen on the left side and district hospital indicated by the red icon with 4 health posts each. The longest route covered is 6.7 kilometers, while the highest altitude difference between 2 landing zones is 900 meters. Here you can see the road travel time from Marchkot Health Post on the top, going down the hill to Bhutan Hospital on the bottom is 4 hours, while a drone can bring the sample in 5 minutes.
Biplav, excuse me.
Yes.
Can you please use the hide button over there? Can you see stop sharing and hide? It's perfect.
Yeah.
Thank you.
Sorry. Yeah. So as you can see, the longest route covered is 6.7 kilometers from Marchkot Health Post, that is seen on the top right corner, to Bhutan Hospital that you can see on the left side. While it takes 4 hours to travel from Majkot to Bhutan on road, a drone can bring the sample in just 5 minutes. Till date, we have conducted 294 flights, collecting 744 sputum samples, out of which 26 have been diagnosed as active tuberculosis patient. This is the first time a drone flight permission was obtained beyond the line of sight with the help of 12 government agencies. The drone flight is currently operational in 8 of the 12 health posts, and we have successfully implemented the precision landing at each health post. Currently, we are planning for phase 2 of this project. The modality of the phase 2 is planned as an expansion to the current drone network with the overall sustainability of the project. We aim to locally operate drones and collect more sample linking to the service remaining to 4 health posts within the 2 municipalities. Moreover, we also want to explore the possibility of using this drone network for transportation of other medicines and sample collection for other diseases. For the sustainability of this project, we aim to train local staffs for operations and maintenance. Drones are the future of transportation as its applications are being researched by numerous companies to incorporate in their operations. Different transportation, logistical, aeronautical, as well as online retail brands are researching on using drones in their operations. I'm confident that in future we'll be able to see drones being used for transportation of humans and goods. For now, we are using drones in Nepal as a medical cargo delivery tool, using drones for rural healthcare. If you have any questions about our project, you may ask them now.
Thank you, Biplav. Biplav, Praveen was supposed to join. Is he joining us?
He hasn't joined till now, right?
All right. No, I don't
Let
think
me
so.
check with him. Yeah.
No problem.
I don't think so. He's coming. Yeah.
Fine, no problem. So, Praveen, I wanted to actually know from you, for example, while employing people there, what kind of teams did you select and why did you select them? Who was engaged?
For the technical part, Hem was engaged, and the quality he had was he was extremely talented in customizing drones, and that was the main reason we hired him. Yeah.
And do you know about the difficulties that he had living in Bhutan? Because I don't know if he's from Bhutan or is he from somewhere else, or how did you
No,
manage?
he's from somewhere else, but he had the initial difficulty to stay in Bhutan. But right now, he is staying there and he's continuing his education, and he just has enrolled in a local school over there, and he's been staying there since the start of the project.
Interesting. How old is he?
He's 20 years old.
He's 20. Amazing. Nice. And so, how many people from Kathmandu were engaged in Bhutan?
Praveen was in the field. He's also from Kathmandu, and I was remotely working to oversee all the operations. And Uttam Pudaseni, our NFL coordinator, he was also involved.
Amazing.
So it was overall 3 people, and one of us was on the field.
So, in the future, do you plan to engage more people from the local village itself in this project?
Yes, yes. For the sustainability of the project and to cut down the cost, we have to do that, and we plan to do that in our phase 2. We plan to bring on more people from the place itself and employ them with a different responsibility for the project.
And are you planning to include more use cases beyond tuberculosis for this thing?
Currently, as the network and as our health partner is based with this disease, uh, but maybe in future we can use the same network, and we want to explore other diseases to be used by the same network. And adding to that, I think transporting other samples which are not temperature sensitive is doable, as we just need to change a few compartments inside the cargo box, which can be easily 3D printed.
Okay. Can you talk about the cargo box itself? What kind of box this is and what are the qualities of this box?
This is a simple 3D printed cargo box, 3D printed with fusion deposition modeling, which is FDM 3D printer. It is a simple desktop 3D printer that you can find anywhere currently. And we have used ABS filament, which is one of the most common type of filament. It is made out of plastic, and the inside compartment has been made to aid the proper alignment of the sputum samples. And with computer aided designing, we can change the design in any shape, and we can print that in less than a few hours.
Okay, and so this box is not maintaining temperature inside. You're not doing any temperature monitoring or anything like that.
Yeah, for temperature sensitive samples, we need those kind of materials which are very hard to 3D print,
Hmm.
and they need to go through different kind of manufacturing processes.
Oh, okay. So because you have a very low transport time, it's just 5 minutes. So you don't need that kind of a temperature sensitivity, or is it that for tuberculosis samples in general, you don't need to maintain a temperature?
For tuberculosis samples, and also the fact that the travel time is very less, we haven't used the temperature uh, uh, materials. But yeah, if we try to transport other things like a pint of blood or uh, other samples, we need to make sure that the boxes uh, are made with special materials.
Okay, okay, got it. And do you also follow some kind of safety measures for biohazard risk? For example, if in case the drone crashes or if in case the materials leak out, something like that, have any of those things been thought about?
This is a very good question. Regarding the medical biohazards, I don't think we have such protocols. We do have protocols for drones, drone crashes, and other standard operating procedure. But especially for the sputum sample inside the cargo box, we haven't really thought of it. Maybe we should put that in our task list.
Great. And secondly, have you had any crashes, any incidences in the last 1 year?
Uh, since it has started operating, we didn't have any clashes. But before the inauguration, while we were testing for one flight, we had a crash.
Okay. And how does M600 behave in the hilly regions? Is it being nice, or you thinking of some other drone?
So sorry, come again.
I'm saying, is M600 great for the kind of terrain we're talking about, or we may consider some other drones for a project in the future?
Uh, we can use any kind of multicopter,
Hmm.
uh, but we use M600 as it has better payload carrying capacity.
Got it. So there are some more questions from the students, and I would put them to you. And we also have Uttam over here. So in case you need some help from Uttam, he's always around.
Yeah.
So we have a question. Could you please, okay, how problematic are power lines in cargo delivery in your case? Did you have such problem when you were executing your project?
So power lines, as in the transmission lines.
Yes, the transmission line or the wires, the dangling wires or
Yeah.
any of the
So
cables.
so the drone routes were carefully developed. Uh, So all the obstacles that were on the routes were foreseen before, and in such way the routes were predefined. And adding to that, we also had two or three kind of routes depending upon the time of flight, because sometimes when you need to go up the hill, you can go through two different routes according to the time of the day, because the wind force is different in the morning and in the daytime.
Oh,
So for some routes we had version 1 and version 2. So the routes were predefined, and no of every obstacles were thought of while designing the routes.
interesting. So that much hard work has to go in before you start operating, right?
Yeah.
Okay. So Mayank is asking, uh, can you explain or can you give some more details about the overall timeline and how long each phase took? So you had a 8 phase program, right? So how
Yeah.
much did each phase took? How much time did each phase take?
I think Uttam Dai can answer this more.
Maybe you can show the slide, that slide.
Okay. Hello. Hi, Ruchi. Can you hear me?
Yes, Uttam. So everybody, this is Uttam Padasani, who is the coordinator for Nepal Flying Labs.
Hello, everyone. Namaste and good evening. So I would like to add to what Biplav just mentioned about the project period. So when we started working on the project, initially we worked on the assumption that we would easily get the permissions from the government because the Ministry of Health itself was a part of it. But when we started working on the approval process, it took us around 7 months to get the government approvals. So one trick to do this in a quick time from next phases is that when we apply to Civil Aviation and Home Ministry for approval process, it would be a lot easier if we get some kind of recommendation letter from the local governments. So what we did when we apply for the second phase permission, we received some letter of recommendations from the local governments, and then we visited the ministries to get the letters of permission. And on the second time, it was more easier because the ministries could feel that there was a strong ownership from the side of the local government. So when we talk about the project phases, the preparatory phase took us around like 8 months of time. And in the preparatory phase, we mainly focused on securing permissions, and the technical team, they focused on doing the flight route plans. So as Biplav mentioned, when we were doing the flight route planning, we made use of available topographical maps, and also we created high resolution map for all of our takeoff and landing site. So when we worked on this high resolution mapping of all of the takeoff and landing site, the maps that we created, it helped us to properly plan where the landing locations would be. So a lot of time is required on the preliminary preparation phase and planning. And once that is done, then it's only about flying your drones on the predefined path.
And after that, Uttam, when you had the other phases, phase 3, phase 4, how much time did the overall rest of the phases took?
So the preparatory phase, as I mentioned, it took us around 8 months. And after the preparatory phase, we had a month of testing. So during that 1 month of time, what we did was, and the technical engineering team from Caerobotics, they came to Nepal, and we did some test flight over the locations that were already fixed. So during that time, our initial assumption was that we would be able to do that within a month of time. But it took us more time because there were some technical errors. So one of the major technical errors that we had was it was very difficult for us to accurately land the drone on predefined locations because like the hospitals, they were at around 6 or 7 kilometer aerial distance, and the radio antennas were not properly working. And also the GPS was not functioning properly. So what we did was the engineering team, they came up with a solution of this precision landing system where they developed a kind of a mat that could be placed on ground. And then the sensors on the drone, when they were in the air, and they could identify those patterns, and then they could follow the pattern and then land on those obstacles. So the second phase was kind of a testing phase after the preliminary preparation. And the testing phase was it went around for like 2 months. And then the third phase was the actual operation where we were continuously operational for around 5 or 6 months. And while we were operational, we had sometime we had to work on some kind of maintenance as well. And I could read in the questions that one of the questions was targeted to how was the maintenance being done in the rural area. So interestingly, when we started working on this project, actually the plan was to bring that guy in this session as well today. So we found this guy who was who is very passionate about drones and who is a drone maker himself. So he was already working on some kind of his own DIY kind of things. So we hired him for the project, and he could do some level of maintenance. And also the engineering team from Caerobotics, they gave a maintenance training to our field engineers as well. So obviously the maintenance was not like targeted to a high level kind of a damage, but some preliminary and basic damage could be easily maintained by our local engineering team. So we had 2 engineers, Praveen and Haim, stationed in the field all the time, and they were working on the maintenance part.
Thank you, Uttam. And there is one question about the funding model. So is it changing or is it same, or what is the funding model like?
So Ruchi, before answering that funding model, if you would allow me, I would like to add something on the biohazard component that you asked before.
Sure.
So when we were working on the actual operation, there were questions raised by our partners regarding the safety of the sample that the drone was carrying. So obviously, in this case, the drone was flying with the sputum sample, so there was not much risk of transmission of the disease. But then another idea that we came up with was we printed on local language writing a message on the cargo box that if anyone finds it, like in case of any damage, if anyone finds it, then we requested them to please not open the box and then call at a predefined at a certain number. So we had that message clearly written on both of our cargo box. So in the first phase, when we were operational for around 6 months, we didn't have biohazard-proof cargo box, but we tried our best to mention that message on the cargo box itself so that any people, in case of any damages or accidents, if somebody finds it, then they could send it back to us, calling out us at the number. So that is about the biohazard question. And talking about the funding model, so the preliminary phase, as Biplav mentioned before, it was funded by Nixon's Foundation and Stony Brook University. So the project, the component that we worked on was only the technical works, but there were also several other components. So there were students doing their masters and PhD on Stony Brook University on some components of the project, and there was also our public health partner, which had their own kind of operational costs they need to cover. So initially the funding came from few donors. And when we completed the first phase, for the second phase, we didn't need, so for the technical operations, we had already figured out what could be the best way to handle the field operations. So for the second phase, the funding model needed for only to provide salary to our field staff and also for the management team. And since we had the hardware on place, we didn't require bigger funding. So that was in the second phase. And the third phase that we were planning, but we have not been able to roll it out because of the current pandemic. So in the third phase, the plan is we are also doing this conversation with the municipality. So we are planning to request the municipality to pay for certain deliveries. So Ruchi, when you asked before, like whether we have in plan to transfer more samples than just tuberculosis sample or not, yes, of course, we have that in our plan. So we want to send certain like very sensitive medicines. Like for example, in case of pregnancy, there is this one particular medicine which could save life due to excessive bleeding. So we want to send to the rural health post using the drones. And if the municipality is interested, like if they could provide us some funding for our operation, or if they could provide us some local staff, because at the moment the project is paying for the local support staff, and in the future if the municipality could come on board and they could provide the money required to support those local staff, then it would be a strong model of co-funding where a certain part is covered by the municipality and certain part comes from the donor as well. But at the moment, the first phase was largely donor driven. The second phase was limited to only support and the staff salaries. And the third phase, we are trying to work on a co-funding model as well.
Okay. And there is an add-on question to this is, has any kind of effective cost of per sample delivery studied when averaged for a month?
Sorry, could you please repeat that again?
What is the approximate effective cost of per sample delivery when averaged for a month? Have you done such a kind of study?
Yeah, that's a very good question actually, and that also helps a lot of other organization and individual to plan their project operations. So that was the financial analysis per sample delivery, and also the financial analysis of the project is a part of the third phase. And we have already received some funding support to do the third phase. We are waiting for the lockdown to be lifted. So probably I will be able to answer that question properly in next few months when we have more data and statistics.
Right. Thank you so much. So there is one more thing. Do you use drones with some fail-safe mechanism like parachutes which are built in?
Yes, initially we had the plan of using, so this question was asked by the Home Ministry as well, because the Home Ministry in Nepal is more concerned about third-party insurance when they issue drone permissions to any bigger drones. So initially they also asked us like if there was a kind of a parachute mechanism available or not. But up to my knowledge, so initially when we applied for this project, we had a plan to use some other kind of drone, and in that particular proposal we had a funding, we had a parachute mechanism also attached to our operation. But for the M600, I might be wrong, but as per my knowledge, like we didn't find a suitable parachute mechanism that could be fitted into M600, so we didn't go for it. But obviously it was in our plan for another kind of drone. But for M600, we could not find it. So if anyone in the audience knows about it, like please send us the link, and definitely we will explore that option as well to add more safety to our operations.
Sure. And Uttam, there is an add-on question about government permissions. Because it took so long to take the permissions, are there any plans from the government to reduce the delay for getting the approvals?
So that the answer to that question would be like yes as well as no, because currently, like before, it was very difficult for any individuals to get permission for drones because they needed to visit Home Ministry to get the approvals. But now when we have this, when the government came up with the drone permission regulation 2.0, now we can get the approvals from the local governments as well. But in case of drones like M600, in case of drones which have weight more than 2 kilograms, the permission process is still complicated. But now, like we are working with civil aviation to develop a kind of a digital solution where all the application process could go online. So, like this is actually an ongoing project that where we have received some level of support from Caerobotics as well, and we are working with civil aviation to do a simulation exercise where we would showcase how some kind of digital solutions could be used to ease up the process. And in next 3 or 4 months after the software is developed, I would be able to provide like whether the government actually like it or not and their response. But at the moment, below 2 kg drones, the permission process is easy. You can visit local government and get the approval. But for above 2 kilograms, you still need to visit Home Ministry, Civil Aviation, and Information Ministry, and which obviously takes more time.
And Uttam, what were the government agencies' main concerns, and how did you convince them?
So the government agency's main concern, so for the different agencies, the concerns were different. So for example, for the Home Ministry, they were concerned about the safety and security and privacy. And for the Ministry of Information, the more concern was regarding the frequency because and the M600 drone, it operates in around 800 plus frequency. And when we initially approached the ministry, they immediately rejected our permission request because that falls into our telecommunication frequency zone, and they could not provide permission for that. So the Ministry of Information is more concerned about the use of our device without accepting any telecommunication frequency range in that particular area. And likewise, the civil aviation is more concerned about the safety of the aircraft. So the three different agencies, they have three different kind of safety concerns. And in order to deal with safety concerns, our approach have been when we go and deal with the Home Ministry, we do the third-party insurance so they can be assured about the safety criteria for the general public and the damage and the drone could cause because of any unforeseen activities. And when we approach Ministry of Information, these days we don't go with those kind of frequency requests. So we first tried to do a research on whether the drone could be operated with lower frequencies, and also maybe like by installing more radio frequency devices in the way. And when we approach civil aviation, what we do is we prepare our flight plan prior to applying for permission, and then we go and talk to them so that they could overlay our flight plan in their existing maps, and then they could provide an answer whether our flight plan put a risk to their current flight plans or not. So that is how we have been dealing with different requests and different concerns from three different agencies.
Interesting. And what about the weather? Rain, strong winds, did you have any trouble from them? How did you combat?
Yes, so when Praveen and the team were operational in the field, we didn't used to operate in strong winds, and also we didn't used to operate in during rainfall conditions. So we didn't have any wind measurement devices with us, but if the wind was quite strong, then we used to halt our operations.
Okay. And there is a question, do you have a plan to create drone port or drone operations center in Nepal in the future? Or if you have that,
Yeah,
what are
actually,
the activities or operations do you have there so far?
so we have a plan to do that, and actually this idea came after we organized this simulation workshop for emergency responders together with the World Food Program Nepal. And we are also in conversation with some of the companies outside which have this kind of portable drone ports that could be migrated from one place to another place. But Ruchi, one big problem that we noticed, that we witnessed and we faced while working in the field was the provision of land space for these drone ports. So when we are working in the municipalities and the health center, it was very difficult for us to have a permission to use a land for a, let's say, like a 6 or 7 month period of time from the local health partners, because they have a limited amount of land and only flat surface available is the roof of the health post, and we are not confident enough to land our drones on the roof of the health post. So the logistical challenge is to find a land area that could be utilized for the drone ports. But in terms of technical support and technology, we are already in touch with some of the partners who are interested to do this. And definitely this would be interesting thing to see in future for drone operations.
Interesting. And
Okay.
what about hacking? Do you have any anti-hacking measures with you?
No, we don't have that.
Okay. Maybe you can think about it in the future. These are the suggestions coming
Yeah.
in from the class itself. Okay.
Yeah, I can see a lot of good questions and suggestions. So how do you want to do this? Like we do this now, or we can discuss about that later in a separate document?
Sorry.
A lot of interesting questions and suggestions on the chat box.
Yeah.
So do you want to go through those questions now, or you want to do that in a Google Doc later?
No,
Whatever
I'm
works for
reading out
you
the
as per your
questions to
time.
you. I'm reading out all the questions to you. and you're already answering them. These are not my questions, these are from the class. Okay. So what about terrain following? What kind of applications can we use for do the terrain following in hilly areas?
Biplav, do you remember the software we used for, I think it was Q ground control. So we
Q
used a
ground
software
control, yeah.
called Q ground control, yeah, for our flight planning. And when we did the flight planning, what we did was we manually selected some points, maybe like some points for the drone flight. And in the Q ground control, the user could see the satellite image in the background, and then they could draw the flight path over it. So we utilized that Q ground control, and also we used topographical as a reference layer to get more updated information on the height of the terrain.
Okay. There is a related question. Have you, what is the height that you prefer for autonomous flights?
So for our operations, like as Biplav showed in his presentation earlier, the height difference between the maximum height difference between the district hospital and the health post, that was around 900 meters, I think. So when we had to fly in the 900 meters, what we did was we didn't like fly our drones up to 900 meters from the ground and then flew it straight. But what we did was we followed the terrain, and then we flew our drones on that particular path. So as per the regulations of the government of Nepal, the drones are not allowed to fly above 200 feet. But for this particular project, we got approval, we got permissions to fly up to, I think, 3,000 meters above the sea level, because in Bhutan, the highest point was around 2,000 meters. So the government requested us like not to fly 200 meters above that particular height. So the maximum elevation of where we had to be operational was around 2,000 meters from the sea level, and the government put a threshold of around 200 meters. And because and this question is also related on the topography of the place and the frequency of other flights in the area. So in Bhutan, like there were not much aeroplanes flying in the sky of Bhutan, but there were sometimes helicopters flying in the sky. And when the helicopters were flying, they were also flying up to 2,000, 2,500 meter altitude. So we are working very closely with air traffic control in the neighboring district. So whenever there was a helicopter flight, we used to inform, we used to communicate with them, and then we used to fly. But talking about our operation, like the maximum altitude was 150 meters from the ground, and the maximum elevation from mean sea level was around 2,200 meters.
And do we need some special kind of sensors on the drone to do such kind of work?
I think no. The already existing sensor in the drone would be able to handle that.
All right, great. So I think these are most of the questions which have been asked over here in the chat by the students. If anybody has anything else that probably is not covered in this discussion, you can just unmute yourself and talk. One question to you is, how confident are you for doing flights which are longer than the current distance that you're doing? So maybe 25 kilometers, 30 kilometers, 50 kilometers. How confident are you about them?
So the biggest problem in this project, which didn't allow us to do more distance flight, was the hardware itself, because the hardware was only working properly when we were operational up to 7 kilometer aerial distance. So I think with this hardware I am not confident enough to go more than 10 kilometers because of the terrain conditions and also the performance of the hardware. But if there is a better drone that we can find in the market, which can do like 25 or 30 kilometers, for sure, we would be interested to use it. But then one of my suggestions would be in a country like Nepal, where the topography is very undulating and where you have to fly, you have to climb up and down through the hills, any kind of drones that work perfectly fine in other countries also needs an extensive testing in the terrain of Nepal before being operational. Because when our engineering team did some tests with M600 in Switzerland, they worked, and the drone worked very fine up to 10-12 kilometer aerial distance. But when we are doing testing here in Nepal, even up to 7 kilometers, it was like challenging. So given the terrain complexities, I am not very confident.
Okay. Thank you very much, Uttam. If anybody has any other question to ask, please you can unmute yourself.
Hello, ma'am. Hello, sir. This is Amit here. So, as there was a question regarding if the drone could fly in highly urbanized area through the power lines, and also, would you like adding RTK with the M600 for that?
Thank you, Amit, for your question. So as Biplav mentioned before, when we created the flight plan between the district hospital and the rural health centers in the far hills, one of our prime concern was to avoid the houses and settlements, and also to avoid any power lines and areas like that, because it was strictly recommended by the ministries that we should try our best to avoid flights over the urban crowded area. So if there are any kind of sensors or any kind of equipments that you think would would add more safety to the drones, for sure we would be interested to do that, because our prime concern has always been the safety of our flights. And if there are any like RTK sensor or any other sensor which could be which could add more safety in the urban area, then yes, we will be interested to use that. But
Okay,
our
sir.
experience was the sensors in the M600, they were not working perfectly fine. I think that was because of the terrain conditions as well, because at some places the hospitals were in an area which were covered by hills on the three side, and they were only open on one side. So maybe the connection was not very smooth because the hospital was located in a lower elevation. But if there are some other kind of equipments that could add safety, then yeah, let's discuss more about it.
Okay, sir.
So there's a question, how would you make your project in the future just perfect? Would you add up something in management, implementation, or evaluation?
Yeah, that's a very, very good question, and it could be an interesting learning for everyone as well. So I would say, like, if I get a chance to add something, then that would be the implementation. Because when we, as I mentioned before, when we started the project plan period was for total 1 year, and we spent almost 7 months securing the permission. So now we have a better understanding of how things work. So implementation would be our implementation strategy. We would be adding more based on our previous experience on the implementation strategy, so that we could make the most out of the time that we have got for the project.
Thank you very much, Uttam. So, does anyone have any other question? If not, then we will call it a day. And I really thank Uttam and Biplav for generously sharing your experiences and knowledge with us. There is one follow-up question. Do ground control point applications will work with iOS or Android? Is it downloadable? Is it a question or Ramesh, is it a question or a statement? I don't know.
Good evening, sir. Good evening, ma'am.
Hi, Ramesh.
Hello.
Yes, Ramesh.
Yes, so my question is this: whether is application working for both iOS and Android, or what is this? Means I unable to know this.
So Ramesh, the Q ground control application, we were using that application not at the time of the flight, but at the time we were doing the flight planning. So what we did was we used the Q ground control software on our laptop. We created all the flight plans, and after we created all the flight plan, we uploaded that flight plan into the drone. So when the drone was operational, we were using a tablet application that was created by our engineering team. And in the tablet application, there were a list of all different 8 routes that the drone could fly. So the only thing that the operator had to do was to choose among those 8 flight routes that were already planned using Q ground control. So the application that the pilot was using at the time of flight was not Q ground control. They were using a custom application that was built by the engineering team. And at the time of flight planning only, we used Q ground control.
So Uttam,
Okay, sir.
how did you change the language? I mean, is it allowed in the app itself, or you created a different layer above it?
So the custom application that was built by the Robotics engineering team, initially it was only available in the English language, but then we realized that our community people who were working, the community healthcare volunteers who would be operating that control device would be a local people, and then we created another layer on top of that application where user could switch language and view both English as well as Nepali language. So it was a new layer on top of what already existed.
Okay, and how difficult was that?
That was done by the engineering team, and it was not that difficult.
Okay, and somebody's
It was just
asking,
programming.
did you have backup rooftops for emergency landing?
Not back. Oh, yeah, that's a very good question, and we forgot to answer that previously. So when you as a project technical member, when you create a flight plan, what you have to do is you have to add some alternative landing site as well. So if you look at the drone flight plan that we created for our flight routes in Bhutan, what we did was we also created some alternative landing site for each of the flight routes. So if anything could go wrong when the drone was in the air, the drone could go and land to any of the nearest alternative landing locations. So we had this pre-programmed in the drone as well, and it's actually a very important thing that you need to do when you are operating in a longer distances. So you define those alternative locations previously when you work on the flight planning, and once these locations are decided, if something goes wrong, instead of coming back to the home point, the drone could go and land on any of these alternative landing points. And this has to be decided very carefully because you need to make sure that the alternative landing site is clear at the time the drone lands.
These
So
landing
yeah, those are
sites
very important.
are still the government buildings, for example, the government hospitals or
So
something, or it could be
unfortunately, that was not
somebody's
the case.
house, it could be somebody else's property, or how does it work?
That could be anything, Ruchi, depending on where you are operational. And in our project, what we did was the locations that we chose for alternative landing, they were the agricultural field of the farmer. And at
Okay,
the time, the agricultural field were
and
barren, so that was quite easier. But
you had
that's
an
not going
understanding
to
with
happen.
them. You had an understanding with them
Yeah,
just
we
in
had an
case this happened.
understanding. Yeah.
Okay,
So if
great.
Biplav, I could not join the presentation earlier, but if Biplav had mentioned in his presentation, so that was the main part of our community engagement discussion. So we organized community engagement session for like 4 or 5 rounds. So in one of the community engagement session, we invited the chairperson of all of the ward offices. And during that community interaction, we passed this message to the ward chairperson to get the permission of using those land areas because it's not possible to go and talk to everyone in the community. But if you go and talk to the ward chairperson, they are the one who will be transferring this message into their communities. So yes, we took the permission and we disseminated that information through the help of the ward chairperson.
Okay, so Mariam is suggesting that are there any more evidences or articles we can read about landing site planning? She hardly found anything about it. Same here, Mariam, I didn't find anything about it. So maybe Uttam, you can write a paper about just how do you manage your landing sites.
So I'm not sure if all of you have know about this, but we have published a 60-page report of the DROTS project. So we would be happy to share with you all the report. And in the report also, you could find some details on what are the kind of challenges that our team faced and the details of all of the phases that Biplav just mentioned. So the report will have some information, but for the very detailed information, yeah, as Ruchi suggested, that could be an option
Yes.
we
Mariam,
can
this
work
will be a
on.
part of your referral reading tonight. And I would, not tonight, maybe tomorrow, I'll add it to that. And Umang is asking how many active members are there who are handling this all and how? Hello, am I audible?
Yes, Ruchi, you are.
So somebody is asking how many active members are there in the team who's handling this?
How many, sorry?
Active members.
So there are 2 pilots in the field and there are 2 support staff to help those pilots. So in the field, we have 4 staff, and in the office, we have 3. So it's Biplav, me, and Darpan in the office who are working mostly on the managerial thing. And in the field, we have 2 pilots and 2 support staff. So altogether 7 people.
And so the role of health workers in this entire thing is just to press that button on the app or just to send the drone back. That's all, right? Is there anything else?
No. So, sorry, I just missed about. So I was answering from Nepal Flying Lab point of view only. But on our healthcare partner, they have their own like setup of field staff. So they have community healthcare worker, one healthcare worker in each of the ward, and the role of the healthcare worker would be to go and visit individual patient houses and collect the sputum sample, and then bring it to the health post to load it into the drone. So they have community, they call it community healthcare mobilizers, and also they have project manager in the field who are handling both public health as well as the drone component. And also there is another component that we have not presented during the presentation, and that is there is a special kind of device called gene export machine, and there are people in the field who are handling the gene export testing. So when the sample is collected and brought to the gene export machines, the gene export machine does the test and give an answer whether the sample has been tested positive or not. So there are a lot of people on the public health side who are working, but I was answering only from our technical team perspective on.
All right. They are trained in opening the box.
Yeah, they are trained public health persons.
Using the app, but they don't do any kind of maintenance, right?
Ruchi, adding to that, they don't really do maintenance, but in case the drone fails to land, or in case they see some malfunction in the drones while landing, they can actually switch the automatic system into manual, and then they can use the tab, and there is a virtual joystick, just like the controller, and they can manually land the drones.
Nice, interesting. Great. So I guess we have come to the end of our class today, and this has been a very interesting learning experience from me. Thank you, Biplav. Thank you, Uttam. And in my country, or in all the countries that all the students are here from, I think they would get a good lesson to take back home tonight. Thank you so much for your generous sharing. And I hope everybody now is ready for the assignment tomorrow, because that is going to be something similar to what you have learned today. And thank you so much, Uttam, again. Once again, good night, everybody. We will see you tomorrow.
Thank you, Ruchi, for inviting us. Thank you, everyone.
Thank you, Ruchi.
Thank you, everyone.